Audio Jungle. Audio Jungle.
So we had seen that this was the bar, and on this we had stress sigma y. This was sigma y, this is sigma x, and this is what? Sigma. Okay. Now suppose here we have a plane somewhere. We just say this is the oblique plane, and the inclination from the vertical is theta. So sigma n and tau we had calculated. At the same time, we also had calculated the principal plane orientation and the stresses on the principal planes, right? So we had calculated sigma 1. This is the major principal stress on principal plane, and that formula was sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square, and this value was in root. Okay. Similarly, this is the minor principal stress on the principal planes, and this was sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 whole square plus tau x square, and this was in root, right? So from with the help of this two equation, we had calculated tau max also, and what we got tau max, it was sigma 1 minus sigma 2. This is very important relation that we had derived in last class, no? Fine. This is the one thing. Second thing, if you add this sigma 1 and sigma 2, then
divided by 2.
Sorry. If you add this sigma 1 plus sigma 2, then what will happen? So if you go for this is divided by 2. Sorry. Yes. So if you add this sigma 1 and sigma 2, then what will happen? That we need to check. Okay. So two equation you have. Okay. You add it. So here you will have sigma 1, sigma 2. So check that root value in root, it is same, plus minus. If you add, then this value will be cancelled out. So what you will have? You will have sigma x plus sigma y. So this is very important result as well as relationship that you need to remember. If you add that to equation, you can try by your own also. So what is the mean of it? So meaning is very simple. If you say, and this is also, see, like if you write sigma 1 plus sigma 2, or also you can say sigma 1 plus sigma 2 by 2 sigma x plus sigma y by 2. That also you can write. What is this sigma 1 plus sigma 2 by 2? You can say this is the average stress. You can say this. So if you talk about the average stress, so it will be sigma 1 plus sigma 2 by 2, as well as this is also sigma x plus sigma y. This is also called average stress. So average stress will be same, okay, on the even on the principal plane if you talk, or the normal stresses on the bar, that is sigma x plus sigma y by 2. This is also a average stress. Okay, so average stress doesn't matter what is the plane, that average stress will be same for the principal plane as well as for the normal plane also. Okay, that's the meaning of it. You need to remember very important, this result sigma 1 plus sigma 2 is equal to sigma x plus sigma y, that you need to remember. That you need to remember. So you had seen, suppose this is the bar here, okay, member or bar you can say, and for this member this is what sigma x, sigma x, sigma y and sigma y. You say there is the plane which is called principal plane, and you are considering this principal plane is here. This is the principal plane 1, P1, and this is the principal plane 2. I had explained two principal plane you will have, major and minor. We say this angle is what, theta. Okay, so it doesn't matter whatever the P2 which is the minor principal plane, and here the stress is minor principal stress sigma 2, and this is P1 is the major principal plane, and here the stress is the major principal stress sigma 1 and sigma 2. Okay, so now for this bar, this is sigma y, this is sigma x. So sigma x plus sigma y by 2 will be the average stress for this bar, even though if you go and calculate on the principal plane also, if you take the average stress, so this sigma 1 plus sigma 2 by 2, so that average stress will be constant, you can say. Okay, all right, that you need to remember. This is very important. Fine, now we are going for the Mohr's circle. So before entering into Mohr's circle, I think few things I am missing, which is called plane stress condition, that I think I had discussed. Plane stress and plane strain, two conditions are there. So okay, we'll do it in later, no problem. First let us start this Mohr circle. After in last we can do that, no problem, not a big problem. Okay, so now we'll go for the Mohr circle. So always remember, Mohr circle is the graphical representation. Okay, Mohr circle is the graphical representation of the stress system. And like for we have a stress system like biaxial, a 3D stress system. So Mohr circle we can draw for both. I mean, you can draw Mohr circle for the bi-stress system for 2D, even though for 3D also you can draw. Here we are going to draw this Mohr circle for the 2D system. So means plane stress condition. Plane stress condition means that z axis or perpendicular to the xy plane, which is nothing but z. So thickness you can say negligible. So z axis stresses will be negligible, sigma zz, tau xz, tau iz. I explained that plane stress condition. So you are considering 2D system and you are going to draw a Mohr circle for the plane stress. That's the reason it is mentioned plane stress. Plane stress means you are going for 2D systems. So now we have Mohr circle. Mohr circle for plane stress, for plane stress, or we can say biaxial stress, or we can say it's a 2D stress system, right? Anything you can say, 2D stress system or biaxial, or you can say it's a plane stress. So that's the meaning is same. That's the meaning is nothing but it's a that sigma z, tau xz and tau yz will be 0. That's the mean only. Now, so if you draw for the for this, if you draw the more circle, so we have the some assumptions, and always remember the more circle is what defined. It is defined for the, it is used, or you can say it is defined the stresses, but in graphical form. Okay, in graphical form. So it's a graphical, better I will write this more circle is what graphical form of stress. Okay, or graphical representation, or you can say plane stress can be graphically represented with the help of this Mohr circle. Okay, that's the mean of it. Now if you check whatever we have here, that value, which is nothing but, if you write the equation for Mohr circle, then we have the same equation like principal stress sigma 1 sigma 2 we had seen that. So that only we have to write in different format, like that radius. Okay, first of all I will tell you why it is called Mohr circle, because whatever the stress system we have, that stress we can write in terms of equation of circle. So I will show you that. It's very simple only. We had seen that normal stress for the plane, if this is what bar here, biaxial stress system, you can show sigma x, this is sigma y. Okay, now you have one plane, you can say this is nothing but here you can take, this is what theta, for this oblique plane sigma n and tau. So now I'm taking this oblique plane here. So for this oblique plane I must say this is what A, this is what B, and this is what C. We have theta here. So what is the sigma n? That is normal stress. Tau is the shear stress on this oblique plane. And you know that formulation, let me write again, it will take very short time of periods, so I should go fast little bit. So it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, right? And if you go for the tangential stress, shear stress on the oblique plane, then it is nothing but sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. So this two equation you have, with the help of this two equation, we can rearrange this equation and we can convert it into the equation of a circle. It's very easy. So what we'll do, simple, we can have this, if you rearrange this, then what we will have, sigma n minus, you can take this sigma x plus sigma y by 2 is equal to sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. The same we just rearranged here. Okay, and tau already we have, so you can say this is the equation number 3. So check sigma n and tau, and we have a coordinate which is based on inclination, that theta we have a 2 theta. Remember this theta is what 2 theta. Now if you check 1 and this equation number 2 and 3, if you convert this in the format, and then you will get here sigma average, which is nothing but sigma average, which is nothing but sigma x plus sigma y by 2, and r we can take as sigma x minus sigma y by 2 square, and this is what tau xy. We are assuming this. So wherever we'll get sigma x minus sigma y by 2 whole square plus tau xy, there I can put r. Wherever we'll get sigma x plus sigma y by 2, we will write sigma average. Now with the help of this, what we can write here? We can write sigma n, whatever the equation we have checked from equation 3. What is the equation 3? This is the equation 3. So from here we can write sigma n, and you can check this sigma x plus sigma y by 2 I have taken it is average, so we can write sigma average. Okay, square it plus check the rest mathematical model you can do by your own. If you do that equation 3, convert it into this format, so you will get this value. This is r square. If I write r square, that means sigma x minus sigma y 2 whole square plus tau x square whole square. So this value you may get. So finally, if you check this, see I have skipped 4-5 steps you can do by your own. Well, this equation you have to use, and this is your sigma average, sigma x plus sigma y 2, and wherever you will get this value you can replace by r. So that rest steps you can do, 4-5 steps you may do, then you will get this final result, this equation. So this is what, this is the kind of the equation of circle, right? This equation of circle, if you remember, generally if a circle is what at origin, then it is x square plus y square is equal to a square, where a is the radius, x and y are axis, but here instead of x, this is nothing but x minus a, you can say. Okay, sorry, x minus, you just make it r, you can say, better you write r, fine. So this format is what, nothing but x minus a is one constant you can take here, so y square is equal to r square. So this is the equation of circle, you all know, equation of circle. And for this, if I say if this is the equation of circle, then what is the center? So based on this you can say radius is nothing but r, and center is nothing but that a comma 0, because we have here a, that constant, and for y we do not have any constant, so you can consider 0, so center will be a comma 0, that you know. So similarly here also, if you compare this, then you will get this is the equation of circle, and for this what will be the center? So center for this circle will be, this is very important, what I'm writing you need to remember, this one you need to remember. Okay, so center will be, the constant is what, sigma average, so we can say sigma average comma tau xy, we do not have any constant term, so we can take 0. Tau xy is just like y, sigma n is just like x, sigma average is the constant value, it is just like a. So for this equation of circle, and if you write center for this circle, so it will be what, a comma 0, that you know very well. So similarly here it is sigma average comma 0. What is the sigma average here? So this is sigma x plus sigma y by 2 comma 0. This is nothing but what, center. This result I have, I'm again saying this result directly I am writing here. In between 4-5 steps you will have, okay, you have to rearrange this equation number 3 and 2, you have to rearrange, do some mathematical calculation, square and add, do something, then you will get finally this result, and directly I'm writing this. So basically this is what, equation of circle, hence Mohr is the scientist name, so that's the reason, based on his name they have written Mohr circle. So all the calculation now, normal stress, sigma x, which is the stress on x plane or face, and y respectively for y face is sigma y, principal plane stress sigma 1 and sigma 2, everything, tau xy is the shear stress on xy plane, and obviously on oblique plane it will be tau. So every stresses you can represent here in the circle. Okay, consider the circle, and over the circle you have to represent all the stresses. That's the reason it is called a graphically representation of the stresses is what considered with the help of this Mohr circle. Okay, that's the mean of it. Now what will be the radius? So radius already you have defined here. Here you have taken r, so this r is nothing but sigma x minus sigma y. So now final conclusion I am going to write, because we have to go directly, we have to go for the different cases. So final result I need to write. So what is the final result for the first of our equation of circle? We need to write equation of circle, equation of Mohr circle, better, Mohr circle. You need to remember the center of the circle, center of Mohr circle. Third, we need to write radius of Mohr circle. Why I am writing directly this value? Because now this is for you. I mean, this is important for you. Nothing else. This is important only. Okay. So this value is nothing but equation of Mohr circle. You had seen that value. It is nothing but, let me take another color so it will be more visible to you. This value is nothing but it's a sigma n minus sigma average plus tau xy is equal to radius. It's a radius r square, number one. Number two, center of the Mohr circle, it is nothing but or, you please remember, because question directly they are asking for this. So three points I have given. You need to remember this notes. Okay. And radius of the Mohr circle is nothing but r. You already have written sigma x minus sigma y by 2 whole square plus tau x square. Also, if you remember, this value was in my last lecture I had explained. This value is also called tau max. This value is also called tau max, if you remember. And this tau max is also sigma 1 minus sigma 2 by 2. You always remember. So sometimes this is the MCQ question also. The radius of Mohr circle is what? Is sigma x or sigma y, sigma x minus sigma y, or tau max. 4 options will be given. So radius of Mohr circle will be always maximum shear stress. That you need to remember. Okay, always. So this is the one question. Fine. Now for what this equation you have achieved, so that diagram also you need to remember, because this Mohr circle is not lengthy. It's a actually in semester examination and all, they are asking for 8 marks question. So I'm not going in so much deep and detail, but in short I'm just explaining you the important parts or the outcome of the Mohr circle. I'm explaining you please remember this. That's all. If you remember this only, then you will be able to solve the problems, and that is our main motive, right? Where is the tau xy, and this is nothing but, for this stress system we have written this Mohr circle. Okay, sigma x sigma y tau xy you are getting here. So for this only we have written. Okay, anyway, now where is the sigma n and sigma tau? So you can say this is the oblique plane. Here you have taken angle is theta, so this will be what? Sigma n, and this will be what? Tau. All right, fine. This is what sigma n and tau. So for this diagram we have written all the equation here. Fine. Now the time is these stresses sigma x, sigma y, tau xy, everything. I just want sigma 1, sigma 2. I just want to show you on the circle. Okay, that will be important. And always remember this radius of Mohr's circle is tau max. This they have asked question. Okay, in another one day exam they had asked already question. What is the radius of Mohr's circle? So option will be like major principal stress, minor principal stress, maximum shear stress. So answer is maximum shear stress. That you need to remember there. Okay, now now coming to the points, like see that first of all it is like I will draw for complete one, then we have steps. Okay, we have even step also to write everything. So what we have the cases. Cases is like if sigma x and sigma y are the same type of stress. What is the mean of it? That means are the stresses are like stresses. Like stresses means if both are tensile, then it will be the like stresses. If unlike stresses means one is tensile, another is compressive. That's the mean of it. Okay, if it is like this, then how to draw the circle for that kind of stresses, and how you will represent sigma x, sigma y and all. Understood or not? So now basically we have here the points. First case, which is nothing but the one simple case I will take, and I will show you. Like if you draw the circle here, so like for 8 marks they will ask, okay, like draw the circle. So drawing the circle, the concept is step by step it is different. So I'm not going to tell you the steps like how to draw the circle, because they are not going to ask. Here directly I will draw the circle and I will name all the stresses. You understood my point or not? So we can save our time in that way. Otherwise there is the method like how to draw, where we have to take the arc, all those things. So there is the steps, and they in semester they will ask for 8 marks. So that time you need to write each and every steps. Like first we'll draw the x-axis, we'll draw the y-axis. On x-axis we'll draw the normal stresses. On y-axis we draw the shear stresses. Then we'll consider the center point somewhere for the circle, and how center will be decided. So all the measurements by the scale we have, that is steps. So that I'm not going to do. I'm going to do, I'm just going to draw the circle directly, and in that circle I will explain you and I will name all the stresses, so easily you can understand. Like here you see, you will understand that what is my point. Directly here I'm not going to tell you what is the method to draw the graph Mohr circle, because that is not important. Important is if I have drawn the circle, then first you should know where are the stresses and where we have to draw. Okay, for different stresses, because we have many stresses, sigma x, sigma y. So I'm considering this is the circle. Okay, I'm considering this is the center of the circle. This is the center of the circle I'm considering, and I have drawn one circle. Directly you cannot draw. I told you with the given data. Okay, they will give like 20 megapascal sigma x, and 10 megapascal is what sigma y. Tau xy is 15 megapascal. Inclination theta is this. So based on all the parameters, you have to take the scale. You have to take x-axis measurement, y-axis measurement. You will scale like 10 megapascal is equal to 10 mm. So for 25 megapascal, this will be the value like 25 mm or something, whatever the value. So 25 mm measurement you will have. So that is not required to do here. That it is not semester exam. You are not going to write each and every steps. So that is not required. I am just drawing circle directly here. And obviously this is the x stress, so you need to remember that on x-axis always you have to draw the normal stress, and on y-axis you have to draw the shear stress. these steps is required, so I will tell you this. Now on the x-axis it is sigma, so you can understand, like on x-axis now you will draw the sigma x, on x-axis you will draw the sigma y, on the x-axis you will draw the sigma 1, on the x-axis only you will draw the sigma 2. But if I say I want to draw the tau value or tau max value, then where you will draw? You will draw on y-axis, because y-axis is the shear stress. Okay, it's not tau xy, you just say only tau. Now it is fine. So y-axis is the shear stress, x-axis is the normal stress. In this way you need to remember. Okay, so somewhere you have drawn the center, so you can say this is the center point. Now going for the representation, so this point I can say this is O. Okay, this is what I will just say this is nothing but A. I can say A. This is nothing but I can say this is what B. Okay, one by one. This is the center O, or you can say this point is what C. So it will be easy. C for center. And one more point here you can draw. What is this? I will tell you. This is point D, and what is the mean of it? That also I will tell you. Okay, D, and somewhere below of this you can say this is what E. All right, one more point you need to take. This is called, this is E, hence this is F, you can say. Okay, if this is F, then this you can say this is what G. Okay, this is what G, and somewhere also you can drop this, so you can consider this is what H. I will tell you each and every meaning. Okay, now coming back, that theta you can consider this is the 2 theta. Okay, because you have angle, no? For this bar, if you check here, this theta you are writing, but in the formula of sigma n and tau, what you have, it is 2 theta. Check, this is the 2 theta. So for this equation you are having 2 theta, so based on that you are drawing the circle. So this angle is what 2 theta. Now we'll give the naming here. So this point A is nothing but this point A is nothing but, here I will draw the, here I can take this as measurement from this axis. So this is nothing but called sigma 1. Okay, so what is this point? This point will be sigma 1, principal stress on x-axis, and this sigma 1 is the principal stress is okay, but it's a major principal stress, and at this axis y value will be 0, so sigma 1 comma 0. So this is the coordinate, okay, for this point A. What is the coordinate? Sigma 1 and A. Similarly point B also we have to draw for this. So this value is nothing but called sigma 2, and if you say the coordinate of this point, so this is the minor principal stress sigma 2, and on this axis y will be 0, so sigma 2 comma y, sigma 2 comma 0. This is the coordinate for point B. So with the help of this I am just representing all the stresses. I'm not explaining you how to draw the circle, because that is not the point for the gate. How to draw the circle, that is not a point. For the circle, all the stresses representation is important for you. Okay, that I'm explaining here. Similarly, just like here you have drawn this, so here also you can draw the perpendicular. Now coming to this point, this value. So F point, so for the F we have sigma x, okay, and similarly we will have a sigma y. So for this point F and point G, you can say point G and point F, take other color. So from here you can take, so this G coordinate, okay, I'm explaining G coordinate. So for the G coordinate, check, I am just writing x. So what will be the value of for the G, what will be the value of x? It will be the sigma y sigma y is the normal stress, hence it is on x-axis, and y-axis it will be the tau xy. So sigma y and tau xy is the g coordinate. Similarly, for the f coordinate, we have a sigma x comma tau xy. So tau xy is the shear stress. So if you are going below this reference line, so value will be negative. So you have written sigma x tau xy, because this tau xy and this tau xy both are same, but one is upper from the reference line, so it will be positive. One is another is what downward, because tau xy means it is representing at this point. So this is what tau xy, and similarly here also this is the tau xy. Similarly, this point you can say from here it is nothing but sigma y, and similarly this point from here it is nothing but sigma f. Don't say sigma y is the y, that means it will be in y axis. No, sigma y is the normal stress, hence it will be on x axis only. Always remember, okay? Coming to this, next is point D and E. So this D point is the peak point, okay? Like on y-axis, if you check, D point will be the peak point. Y-axis is what? Shear stress. What is the peak or maximum of tau? Is nothing but tau max. So it is very clear at point D, y value will be what? Tau max. What will be the x value? That is important. So what is the x value? It is nothing but sigma. Okay, or you can say sigma average, or sigma, you can say, I will write sigma average better. I should give clear point, otherwise you may get confused. So this D is sigma average x. Yes, tell me, dear.
Sir, this sigma x till only h.
Sigma x is
F till only f. You have written.
Yes, sorry, yes, it should be only yes. Yeah, yes.
But sir, you have made till.
No, understand. Yes. Thank you. This should be only this value, right? D point is what? The sigma average, or sometimes it is denoted by only sigma dash, or okay. So that will be the distance of center. No? So distance of center, this will be the sigma average, and this sigma average you had seen. I had explained sigma average. Again, I will write if you want. It is nothing but sigma x plus sigma y by 2, or it is also sigma 1 plus sigma 2 by 2. Yeah, that already I have written. Now you can check center if you want to calculate, then how you will get this center. So this point sigma x, this point is sigma y. If you sum both and divide by 2, then center you will achieve. Otherwise, here also you can check. Sigma 1 is what? Point A. Sigma 2 is point B. You add both and divide by 2, so average point you will get. Average means mid of the circle you will get, because one point is what? Ahead to the circle, one point is just behind to the circle. So in between to the circle, if you want the point, then you will take the average. So sigma 1 plus sigma 2 by 2 will give the center, or you can say sigma x plus sigma y by 2. If you do that, then center you will get. So this center is location in x axis will be the sigma average, and y axis, I told you, this is the peak value or maximum value in y direction. Y direction is tau, so maximum value is what? Tau max. So this is nothing but tau max. Similarly, for the point E also, what will be the coordinate? It is the same. D and E both are same, but the thing is, x will be positive, but y-axis will be negative. What is the y-axis? If this is what? Tau. Okay, if this is what? Tau, for the f, so this value is nothing but tau max. Here I should draw a pose. This value is nothing but tau max. So this is what? Tau max. So tau xy is always less than tau max. Similarly here also, if you draw the tau max, so it will come here. So tau max is what? More than tau xy, and that is true also. So sigma average minus tau max. Done. So I think I have drawn everything. All the, stress like sigma 1, sigma 2, tau, sigma x, sigma y, tau x, y, tau maximum, tau average, everything I have drawn, I have represented here. So here directly I have shown you, okay? But actually the steps are different. Steps different means how to draw the circle. So that is the secondary things. I mean, that will be asked for 8 marks in your semester. We are not going to write all the steps in our gate exam. Step number 1, we have drawn x-axis. Step number 1, y-axis, on y-axis, shear stress on x-axis, normal stress. So that we are not going to write. We need to understand if we have drawn the circle. So if the points are given like point A, so immediately you should know point A must be a maximum principal stress or major principal stress. If it is drawn the circle at point B, if point B we are getting, then you should know at point B what should be there. So it should be minor principal stress. What should be the point D? So immediately it should come in your mind. Point D is connected to the center, so center distance from the origin is sigma average, and y-axis for the point D is tau max. That should come. Okay. What is the F? What is the Z? All those things you should know. So this is what H. Similarly, this is what I. Here you can say this is I. It's your choice. So this one is clear or not there? Or you want a step by step?
Sir, clear, sir.
Clear na?
Yes, sir.
See, one way is to go for step by step and then draw the circle. Another thing, you draw directly circle if you know the things and then represent all the stresses. So first draw the circle and represent the all the stresses is the gate point of view approach. And step by step we'll go all the steps and then at last we'll draw the circle. That will be the semester approach. So we are not going to write semester exam, we are going to write the gate exam. So for gate point of view, I have approached, I have drawn the circle directly, and then I have shown you all the points and I have represented all the stresses. Hope this one is clear. Now in your gate, what question they are asking, that is important. Okay, that is important. Anyway, first let me finish this few things like the numbering I have given based on this. So what is the CA? Check one by one I will write. So plane wise, so CA is the major principal plane. Okay, I'm not saying major principal stress, I'm saying major principal plane. And what is the CB? So CB will be minor principal plane. Similarly, we have, where is the shear plane? So see, like I had explained, 2 principal plane and 2 shear plane. Here somewhere I have drawn here. So if you go for the principal and shear plane both, so you know that if check, these are the principal plane P2 and P1. This P1 is the major principal plane, P2 is the minor principal plane. So where is the shear plane? Just 45 degree away. Two principal plane, 2 shear plane we will have. So this is the shear plane, and this is also at 90 degree. This is also at 90 degree. Now here, yes, so you can say this is what S2 and this is what S1. Shear plane, principal plane, shear plane, principal plane. This angle is 45 degree and this angle is also 45 degree. Always remember, this angle is 90 degree and this angle is also 90 degree. That concept you know. So similarly, just here you have written major principal plane, minor principal plane. So we have shear plane. Where is the shear plane? Where tau maximum exists. Where tau maximum is existing? It is existing for CE and CD. So CE and CD are shear plane. Okay. Rest you can write by your own. Like OA is the major principal stress. I can write sigma 1. Similarly, OB is the minor principal stress. It is called sigma 2. OC is the center. Okay. OE is the sigma y, and O, this value OF is the sigma s. So you can write by your own, that you can understand easily. Okay. Why it is HF is negative and why GI is positive? It is because of the shear stress. One will be clockwise, another will be anti-clockwise. That you can make by your own sense, no doubt in that. Now the point is, what question they are asking in your exam from the Mohr circle. So they will give the case there. Okay, cases are like, they will simple say, draw the Mohr circle for the pure stress, draw the Mohr circle for the pure bending, draw the Mohr circle for the 1D bar or prismatic bar. This type of question they will ask. Draw the Mohr circle for the hydrostatic pressure condition. So they will not say draw, they will say which one is correct. Na? For hydrostatic pressure condition or isotropic condition, what is the correct Mohr circle? That type question they are asking in your exam. Hope this one is clear to you. Okay, as I mentioned, 3D Mohr circle is not in your syllabus, only 2D. So this is 2D Mohr circle. You understood what type of question they are asking? In your examination, they will give the cases. They will say for the pure shear stress or pure shear case, or for the shear plane, what is the correct Mohr circle? So they are saying pure shear plane. That means shear stress should exist. There should not be a normal stress. And then what will be the Mohr circle? They will give 4 options. I'll solve few questions also. So you understood what type of question they are asking from the Mohr circle? Yes or no?
Yes, understood.
Right. So now we'll take one by one.
We will solve one more question also, one two question also.
We'll solve it. Yes, if you say we'll solve, no problem. For me, I do not have any problem. I will solve.
Okay.
Yes. So now we'll take different cases, and then we'll draw the Mohr circle for all the different cases. Okay. Fine. So we'll start case 1. Suppose case 1 we have uniaxial bar. For the uniaxial bar, so if I say uniaxial or 1D bar, then it means we can take sigma x or we can take sigma y. So check how to draw. So case 1, 2, 3, like that we have to take. Case 1. Now we have 1D or prismatic bar. We have here for the prismatic bar, suppose this is the prismatic bar here, and for this prismatic bar, and it is uniaxial, no? Prismatic bar, but it's a uniaxial. So only one stress system you may have, which is nothing but sigma x. Now if you want to draw the circle for this, I mean Mohr circle for this, then what you will draw? That is the point. So check carefully, you will understand. It's very simple. Okay, it's very simple, you will understand. So now we need to write all the stresses. We need to write sigma x. So sigma x we will have, I can take this sigma x, I can say this value is nothing but sigma. Okay, if they have not given, even though if they have load also, p load they have given, area will be we have, so sigma is nothing but p by a. But it is very clear it will be sigma x because it is in x direction. So sigma x we have now. What is the sigma x? You can say only sigma. Okay. What will be the sigma y? Because it's a uniaxial, so sigma y will be 0. because it's a uniaxial loading only, we do not have any shear stress and all for this, so that value will also be 0. Now this value is 0. Okay, now coming to the center, if you want to calculate the center, because center, if you want to draw the circle, then you should know center. What is the center? Center is what? OC. Check, OC is the center. Somewhere I have written, not written. OC is the center of circle. And what is this value? Its value is nothing but sigma average. I explain you how. No? OC is the center of circle. That is the sigma average. So now for the circle, because you are going to draw the circle, so you should know the center of the circle. So I can say here center. That is nothing but sigma average. What is the formula for sigma average? I have given sigma x plus sigma y by 2. Any formula you can use. You have two formulas. Sigma x plus sigma y by 2 is equal to sigma 1 plus sigma 2 by 2. So sigma y is 0, sigma x is nothing but sigma, so you have a center sigma by 2, right? Now similarly we should have radius. Radius is nothing but r. What was the formula? Obviously here radius will be what? It will be the BC value, BC, or you can say CH, CA, BC or CA. You can calculate that radius. Or here also you can say this CF. CF is also, you can say it's a radius. So mathematically you can calculate, but I have given the formula, then you can use this formula. Na? What is the formula? Sigma x minus sigma by 2 whole square plus tau xy whole square, root. So that radius you can write here. It's nothing but sigma x minus sigma y by 2 whole square plus tau xy. And all the value are in root. This is the radius. Calculate sigma y is 0, tau is 0. What is we have? Sigma x. We have sigma x is nothing but sigma. So sigma square, sigma by 2 square. That value, if you take root, then it will be sigma by 2. So radius is sigma by 2 and center is also sigma by 2. Now we can draw the circle. How to draw the circle? It is now very easy for you. Simple. You can take x-axis and y-axis. X-axis and y-axis you can draw first. Okay. Here, as usual, as I have explained, this value is nothing but sigma. This value is nothing but tau. I want to draw the circle. And obviously this radius is also tau max. So tau max value will also, it is sigma by 2. So now radius and circle, radius and center both are same. So you can say this is the radius. What is this value? It's nothing but sigma by 2. And this is also the center. So this is the center. Now you draw the circle. So it will touch the origin. I'm not able to draw the complete circle. Please try to understand this. But hope you understood where will be the circle. No? This will be the center now, and for this center you need to draw the circle like this. This is the Mohr circle. Check, radius is what? Sigma by 2. This center will be what? Sigma by 2 comma 0. Yes, sigma by 2 comma 0. Center will be what? Sigma by 2 comma 0. Because what is the center? Center is nothing but sigma average comma 0. Already I have explained you, know. Center is nothing but sigma average by 2. Here, check. And here in the circle also you can check what is the y value for point C. Y is 0. What is the C value? It's a sigma average. So that you have calculated. Now this is the Mohr circle. Is that clear to everyone? Is that clear to everybody? Yes or no? Tell me quick.
Yes, sir, clear.
Right? Now this is case 1. Similarly, we can go for the case 2. So we have many cases. One by one we'll draw. See carefully, listen carefully, check, and any like confusion you may have, immediately you have to ask. Okay, one by one I will write the cases. So this is the Mohr circle. Center and radius is what defined for this. Now we are going for the case 2, and case 2 we can take pure shear case. So we have case 2. suppose I'm just going to take pure shear condition. Okay, if we have pure shear condition, then how to draw the circle? And so before going to the circle, you need to for that particular case you need to write the value of sigma x, sigma y, center value you need to find, radius value you need to find. So you need to find all those values, then you go for the circle. Okay, then you draw the circle. Directly you don't go, and obviously in examination you do not have to draw, you have to check which one is correct answer. Options will be given to you. Okay, so pure shear means what? Pure shear means automatically it comes in your mind, pure shear means only and only shear stress will come into picture. There is no bending stress, there is no direct stress, there is no normal stress, only and only shear stress. Like we have shaft here, suppose this is the shaft. So for this shaft we have only twisting moment, only we have twisting moment. Okay, this is the shaft. Now for this shaft we have only twisting moment, so we have a twisting moment only. So if you take the one element here, so for this element we have only and only twisting moment. Okay, so we can draw this, we have only shear stress like this. Yes or no? Only shear stress we will have, complementary shear stress it's showing. So only shear stress. So we need to write everything. Like what will be the sigma x? Sigma x is 0, no bending stress. What is the sigma y? It is 0. What is the tau xy? So tau xy we can write here, it's this value is nothing but tau, shear stress we have. So this is what tau. Now center if you want to calculate, so sigma average you need to write, it is nothing but sigma x plus sigma y by 2. What is the value? 0. So what is the center? Center is sigma average comma 0, that means 0 comma 0 center. What is the radius? Formula you know, sigma x minus sigma y by 2 whole square plus tau xy root. Sigma xy 0, no? Tau xy you have tau square, and root it will be tau. What is the radius? Radius is tau. Simple. Now you are aware with that what value you will get. No, it's very simple. All right, so here you can say the circle you can draw now. Take x-axis, y-axis. Center of the circle will be origin. Here 0 0. So it will be now very easy for you. So and what will be the radius? Radius will be tau. So you can take this tau value. Just a minute. So we can draw the, and this value will be tau. Now tell me dear.
Sir, first case was for pure sigma stress.
Pure bending you can
Yes.
say. Yes.
Oh,
Or you can say, or uniaxial if you say better. Uniaxial. Don't say bending. Uniaxial stress system. That's all. Uniaxial direct stress.
okay, sir.
So this will be the that more circle for. Okay, you draw the proper circle. I am not able to do here. So and rest everything you can denote. This is what normal stress. This is what tau. Now the point is, where will be the principal stress? If even though in previous case also, if question will be asked to you where is the principal stress, then what way you will answer? Simple. So principal stress, if you check, principal stress in previous case, even though for this also. So one principal stress. Okay, go to the original diagram. Your circle diagram, I mean Mohr's circle. Where is the principal stress at point A and B? So this point A will be the major principal stress and B point will be the minor principal stress. Okay. So now if question will be asked to you, what is the value of the major principal stress? Then simple here, major principal stress is nothing but this value. This is nothing but sigma 1. And what will be this value? This will be the value of radius. What is the radius? It's a tau. What is the value of the principal stress, minor principal stress? It will be this value, which is nothing but sigma 2. What is the value of this? It is minus tau. That's all. And if you remember, major and minor principal stress, I had given you plus minus. So major is plus, minor is minus. Minus tau is the minor principal stress, plus tau is the major principal stress. That's all. The question will be asked, what will be the tau max for this? So tau max is nothing but, you know very well, I explained already many times, it's a radius. So tau max is nothing but this is the tau max. What is the value of tau max? It's a tau only. So any plane where we are getting maximum shear stress called pure shear. Okay. So pure shear stress means where we are achieving the tau max. So tau max where we are getting, it's called the shear plane. So question they also can ask, what is the Mohr circle for the shear plane? Shear planes means only tau. So this will be the, so question will be like center with center origin, center with circle with center 2, 0, circle with center 0, 0 will be the correct answer. I mean, any type question they can ask. I will solve few questions, don't worry. First of all, you should learn for all the cases how to draw the circle. That's my intention here. Okay. Anyway, now coming back to this, pure shear is what done. Okay, in pure shear, like options are, I mean, examples of the pure shear, you know very well. Any element of the on the surface of shaft or any element at the support of beam where the shear stress is what only existing. So in that cases, you will have a Mohr circle with the center 0, 0. That you need to remember. So here I hope you understood. If center of Mohr circle coincides with origin, okay, then it is option they can give pure shear, pure bending, uniaxial, biaxial. So what will be the correct answer? If center of Mohr circle coincide with origin, then it is a pure shear condition. You fix in your mind, okay? You need to remember this. Should I go for next case?
Yes, sir.
Okay. Now moving ahead. Suppose we have unlike stress system. Unlike in the sense sigma x and sigma y, magnitude wise it is same, but both are opposite nature. One is tensile, one is compressive. That's the mean of it. Unlike. And I'm considering only that normal stresses we have. We do not have any shear stress. We can consider shear stress is what 0. Like that we can take the cases. So case, this will be 3, case third. So case third, I am taking the case when we have a unlike stress system. Okay. So unlike stress system means sigma x and sigma y both we have, but both are with same magnitude and opposite sign. That's the mean of the unlike stress. So we have the case, we can take, if here we can write, if we have sigma x is equal to sigma, if we have sigma y is equal to, sorry, this is sigma x what plus means it's a tensile, and it is minus sigma which means compressive. Tau xy they have not given to us, take it 0. Okay, so this is the one thing. Second thing, they can give question like this. They give the diagram and they will say what is the correct Mohr circle for this. Sigma x, they will give like this is the value of sigma. Okay, they will give like this. Second diagram, I mean sigma y, they will give like this, sigma, sigma. Rest they will not give anything. They will not give anything. Only this value they will give. And now they will say draw the Mohr circle, or what is the correct Mohr circle. They will give 4 options for this diagram. So how to execute this? So first you will write this sigma is nothing but sigma x, and this sigma is nothing but sigma y. This is compressive, hence minus. This is tensile, hence it is positive. Now what you will do, first steps is what? Your first step is always, remember, it's nothing but center. No? Then only you will able to the you will be able to draw the circle if you know the center. So center is what? It's a sigma average comma 0. So what is the sigma average? It's the sigma x plus sigma y by 2. Now if you do that, what will be the sigma average? So that sigma average, sigma x plus sigma y by 2, it's 0. So what is the center now? Center is 0 comma 0. First milestone you have achieved. What is the second? Radius. What is the radius? R. Sigma x minus sigma y by 2 whole square plus tau x square. What is the sigma x minus sigma y? Check, both are plus minus, and here it is minus, so minus minus will be plus. So it will be 2 sigma by 2 cancel out sigma is square, tau x y will be 0, sigma square take root, so it's a sigma. So what is the radius? So radius is nothing but sigma. This is the second milestone you have achieved. Done. If you got center, if you got the radius, you will be able to draw the circle. Now we'll draw the circle. For this particular case, they will give this diagram, and for this diagram, this is the Mohr circle. Check. For the Mohr circle, what will be the center? It's a origin. So, and what is the radius? It's a sigma. Katam. Check. Katam. Tata, bye bye. This is the circle now. Katam. Ye ho gaya. This is the Mohr circle for the this particular case. So question will be asked like this only. For that reason, I had not wasted my time to draw the Mohr circle, like its method, how to draw, take this scale, take that scale, take the average, take the division, take this scaling. That is time waste. I have drawn the circle. I have represented all the stresses as per gate point of view. What is the requirement? I have explained, and based on that you are practicing. These are the numerical they are asking in competition. You are practicing the numerical actually directly. Okay, so don't go for the procedure how to draw Mohr circle, not important. That is for semester. For competition, this is the way only you have to study. Okay, so these are the cases, and these cases are the problem actually. These cases are the question they are asking in a competition. So if this is the bar, and for this bar the stresses are subjected like this. Okay, then what will be the Mohr circle? So this will be the Mohr circle. What is the radius here? Radius is nothing but sigma. What is the center here? It's a 0 comma 0. Katam. This is what sigma, and this is what tau. If now here they can ask what is the tau max, so you can say tau max is nothing but sigma. Obviously this is what tau max, and this radius is what sigma, hence tau max becomes sigma. That's all. Okay, fine, done. Should I go for next case? Yes,
Yes, sir.
okay, now going for the next case. We have many cases, and all cases I will draw, don't worry. All cases, it will take hardly 2 to 3 minutes. So next case we can take any one beam. Okay, if you take the beam, then what will happen, that I will show you, and based on that we can sorry we can proceed. So now case 4. So case 4, we are having one beam, and for the beam you can check that beams or beam we can say. For this particular we are talking for this particular beam. So this beam is what subjected like this. I mean stress is what subjected like this. Any beam if you take, even though transverse load is what applied on the beam, when I had explained beam that time I told you transverse load will be applied to the beam. Like UDL load is what? It's a transverse load. If I'm considering this is the one beam here, so if you check the load, so where will be the load? Load will be maybe here or maybe here, or this is the point load, or this is the UDL load. So for the beam, this is the beam. So load can be anything, but these loads are the transverse load. What type of load we have? These are the transverse load. So because of this transverse load, we will have a deflection, we will have a moment, bending moment and all. So even though transverse load is applied on the beam, which is normal to the axis, if I'm considering this is the axis, obviously this will be the longitudinal axis, and perpendicular or normal to the axis if load is what applying called transverse load, and along the axis if load is what applied called longitudinal load. So normal to the axis, the beam, the shear stress will develop between the layers. Obviously shear stress will be there. How shear stress will be there, you can check between the two beams. This is what shear load. Okay. In fact, between the layers also. So, and that time also I had explained that shear loading, because of the shear loading, how that shear stress will exist, that already we had discussed. So if I'll take beam, so for this particular beam, if I will show the stress, so stress will be like this only. Check. Okay, I can say suppose this is the condition. Okay. So normal stress in the direction is always in direction. Normal stress in the direction of load is always 0 in beam. Okay, points if you want to write, you can write like 2-3 points. That first, if it is beam, so only shear load will be existing. Okay, for the beam, let me write here. Tau shear load will not be 0. Sigma x will not be 0. Sigma y will be 0 for the beam. The normal stress in the direction of load is always 0 in beams. This is the statement. If you want to note, you can note down somewhere. Okay, so for the two types of cases we have. Number one, I'm considering if the beam which is like tau shear stress will be existing shear load called shear loading, and that shear loading will be acting between the layers, and tension or compression will act along. Okay, for the beam, if you remember that beam where we had applied the transverse load, if you apply the transverse load here, so it will be deflected like this. So there I explained shear load will be acting, no? Between the layers, so shear stress will come. So this is what tau. Okay, so here we have sigma x is equal to sigma y will be 0, and tau xy we can say it is nothing but tau we have. Now if you want to draw the circle, what you will do, you will get the first center center is nothing but sigma average comma 0. What is the sigma average? Sigma x plus sigma y by 2. If you check, it's nothing but sigma by 2. If you check the radius will be what? Sigma x minus sigma y by 2 whole square plus tau xy, take root of it. Okay, check tau xy is what? Tau, and sigma value you are getting. So what will be the radius? It is nothing but sigma by 2 whole square plus tau square. This is what? Radius. Okay, now you can draw the circle. So in short, I will draw here. I mean, let me take another page better. So what is the center? Center you got sigma by 2. What is the radius? Sigma by 2 whole square plus tau square. Now if you draw the circle for this, what will be the circle? Check this. This is the x and y. This is sigma. This is what? Tau. Now the center will not be a 0 0. Sigma by 2 is the center. Okay, and this is the radius. So center I can take from the, this is the origin. So from here, this center I can take, this is the center. Center is nothing but sigma by 2. Now this will be the center, with taking this center as the point, and radius you take sigma by 2 whole square plus tau square. Value will be given to you. Make sure radius you will get, and if you draw the circle, then circle will be like this only. Okay, this will be the circle. If you check the radius, so radius r, this is nothing but sigma by 2 whole square plus tau. Run. Okay,
Sir,
where will be the sigma? Yes, wait. Sigma 1, which is the major principal stress, it is the sigma 1. Even though if you want to calculate, you can calculate also. Where will be the sigma 2? This is the sigma 2. You know how to calculate sigma 1 and sigma 2. That formula you know very well. Use that formula and get that result. Now tell me.
sir, how did you draw this circle? How did you draw the circle? I mean, this sigma 2 is away from center, sir. So I got confused
Yes,
here.
yes. Listen. I will tell you. Check that your center point from the origin is what? Sigma by 2. So I am considering this is my origin. Okay, now coming to back. No? Just go to the basic, then you will understand how to draw the center. Center is always measuring from the center. See, this is the center for the circle, and this center you are measuring from the origin. Where is the origin? Origin is what? O. So from O to this center distance is what? Sigma average. You remember that? Yes or no?
Yes, sir.
Center is sigma average. Check. What is the sigma average? Sigma x plus sigma y by 2. You calculate that. No? So if you do sigma x plus sigma y by 2, then what value you will get here? It's a sigma by 2. So from this origin to center, this is now center, you just measure the distance, it will be sigma by 2. Understood?
Yes, sir.
Now this value you need to take. Okay, you can ask like, why this this Mohr circle is not like this? I think you are asking this. Why it is not like this? Yes or no?
Yes, sir. Yes, sir.
Correct. So this will be possible when your center and radius magnitude is what? Same. If your radius, because this will be the radius and this will be the center, so center and radius will be overlapping, then this circle you may get.
Yes, sir. Yes, I got it.
No, I think one case was there. Let me check. One case was there. I remember. See this.
So this.
So check radius and center. कहाँ गया? Center कहाँ है? ये रहा. Sigma by 2 and radius is sigma by 2. Hope you
Yes.
understood, ना?
Yes, sir.
Right. So कुछ ऐसा बनेगा ये. ठीक है, इसको हटाओ, ये वाला ऊपर वाला है, कंफ्यूजन होगा बाद में. So this will be the circle. Others also you want many cases. We have another cases, few important cases we have, like isotropic, hydrostatic. These are important actually.
The one which are important in gate.
Yes, yes, all are important. Anything they can ask to you.
Okay, sir.
Yes. Okay.
Sir, we can solve some question, then we can.
We can do that, but I think I should finish this because we are in rhythm and even everything in your mind also, another student also. Now, where is the
Yes.
sigma x, where is sigma y? So better let this finish first. Then we'll go
Okay.
for numerical. We have numerical, many numerical we have, we can solve, no problem. Okay, so two more cases I am just going to take. Another also we have, but two cases are very important that I need to take. I think this was case 3 or 4, case 4. Now we are going for case 5. Case 5. What is the next case 5? I can consider material, okay? Like if it is isotropic material, like isotropic material. So isotropic material means what? That time only I had explained. If property in all direction is what? Same, called isotropic material, okay? Called isotropic material. If property in all direction it is same, then that type of material called as isotropic material. So if you check stress wise, so we are having sigma x and sigma y, and it is like stresses. Like stresses means both are positive, or you can take both negative, okay? So isotropic. Better I will write isotropic condition. Isotropic conditions, it will be more visible to you. Instead of saying isotropic material, actually you are drawing for isotropic material, no doubt, but I'm writing here isotropic conditions. So for isotropic conditions, I can draw first the bar material where the stresses are acting. So this is the bar, and for this bar we have stresses, like stresses, sigma, 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 and same nature forces are acting. Same nature, if say, then we can say only normal stresses are acting, there is no shear stress. So hence it is called isotropic condition. Isotropic condition means in all direction properties must be same. Stress wise it is like stresses in all direction, only normal stress, we do not have shear stress. So I can say sigma x is what? Sigma. Sigma y is what? Sigma. Tau xy, I'm considering there is no shear stress for this, so just take it 0. Now coming for this, we have the value called center first. So center is what? Sigma average comma 0. What is this value? Sigma x plus sigma y by 2. This is nothing but sigma plus sigma 2 sigma by 2, that is sigma. So center we have here sigma comma 0 y. Now coming for radius, sigma x minus sigma y by 2 whole square plus tau xy. Take root of it. If we check, this value will be 0. Tau xy is 0. Sigma x minus sigma y will be 0. Yes or no? So in this situation, what will be the center and radius you got, but what will be the circle? So circle now need to draw. Check. This is what sigma, this is what tau. Where is the center? It's a sigma comma 0. So sigma is the value here. This is value of sigma. So this will be the center now. Sigma comma 0. What is the radius? Radius is 0. Can we draw circle now? Can we draw circle now? Center is sigma comma 0, but radius is 0. Can we draw the circle now? No, we cannot draw. This type of circle, this is very important. This type
Point circle.
yes. This type of circle called as point circle. Done. This is the case 5. Now coming for the next. And always remember, this is the isotropic condition, okay? So isotropic condition I explained many times, like in all direction properties must be same. Take one point, suppose this is the point, and in all direction properties will be same. That means what? See, in all direction properties is what? Same. So in terms of stresses, in all direction it is what? Sigma. No tau, no shear stress, only this. This is called isotropic condition. It is called isotropic condition. Sigma x and sigma y is equal to sigma, called isotropic condition. This is isotropic. So for isotropic condition, what is the Mohr circle? If question will be asked to you, you have to say it's a point circle. So on the surface of thin sphere at a point in all directions, only hoop tension will be acting without shear stress, called isotropic condition. If you want to write, you can write also isotropic condition. Like you can consider thin sphere. Why I'm saying thin sphere? Because you want to neglect that z axis. So thin sphere at a point in all directions, only hoop stresses will be acting. So only one stress you will get, that is hoop stress. There is no circumference. I mean hoop stress will be there. Hoop stress will be same in all direction. That's the mean of it. There is no shear stress. There is no shear stress. Okay, called isotropic condition. That is the one thing. Second thing, I can take another condition called hydrostatic pressure condition. That also you might aware with this. So that is the last case, and last case is also very, very important. Case 6. This is called hydrostatic. So hydrostatic condition, this is also kind of isotropic, but check by nature what it is. So you can take, this is the free surface. Okay, this is the free surface, and we have one block. This is the block, and obviously here we have water, no? This is what? Water. And hydrostatic, hydro means water, static means stationary condition. Just like you can say one vessel is there, and or pond is there, where the water is what? At static condition, and one block you have enter into this water, then what will happen to this block? So over this block, hydrostatic pressure will be acting in all direction, and you know the nature of the pressure. It is always acting normal to the surface. That is the nature of the pressure, and that nature is also compressive nature. You know that pressure, hydrostatic pressure, is by nature compressive. So here also you can say, if you draw the block for this, then what block you will get? This will be the block, because water is what? Is stationary, so there is no shear stress. But if you check the stress, because normal stress and hydrostatic pressure must be same, so all the normal stress, because you know the normal stress also called pressure, okay, hydrostatic pressure, but it is by nature it is compressive. So sigma y, it is minus sigma, sigma x is minus sigma. but water is what is stationary condition, static condition, so there is no tau xy. So I should write sigma x is equal to minus sigma, sigma y is equal to minus sigma, because water is what is stationary. If water is what flowing, then shear stress will be there, but water is stationary, static condition, then tau xy is 0. Now we'll draw the circle for this case. So what will be the center? We go and calculate this. Sigma average comma 0. What is the value? Sigma average, it's a sigma x plus sigma y by 2 comma 0. What is sigma x plus sigma y by 2? If you do it, it will be what? Sigma minus 2 sigma, 2 cancel out, so minus sigma comma 0, right? What is the radius? Radius r is nothing but sigma x minus sigma y whole square plus tau xy. Sigma x minus sigma y, minus plus, minus sigma plus sigma cancel out, so you will get radius equal to 0. Now for this also, if you draw the circle, Mohr circle for this is what sigma, this is what tau. Where is the center? Center is minus sigma. So where is the minus sigma? This is the minus sigma. So this center is nothing but minus sigma comma 0. What is the radius? 0. So this will be the Mohr circle. So this is very interesting actually. So most of time student may get confused. This is also point circle. In one case point circle you are getting positive center, another case it is negative. Check. So for isotropic condition where the stresses are tensile, positive, so center will be positive and this will be the Mohr circle. And so two cases we have practically, hydrostatic conditions and isotropic condition. For both cases we are getting point circle, but there is the difference in between. What are the difference? Difference are hydrostatic condition when you are submerging or any body is what submerged under water under hydrostatic pressure condition. So only compressive stress will be acting. There is no shear stress. Why? Because that condition is what a static condition. You know very well. Shear stress will come when the water is not flowing. Here it's hydrostatic means hydro, water, static means stationary condition. So only normal stress will exist. But it is the pressure. So pressure by nature it is compressive. So only compressive stress will be existing. X, Y, Z, all direction. So this will be the Mohr circle. Now guys, tell me up to here this one is clear or not? Tell me first. Then we'll go ahead. This one is clear or not?
Yes, sir.
Yes,
Clear.
sir. Yes.